Welcome back, Year 10, to the second lesson for today, your geography lesson. We're looking at another landform, or kind of paired landforms, much like waterfalls and gorges were. We're looking here at Meanders and Oxbow lakes. We're going to be able to identify them. You need to be able to look at photographs and easily pick out which landforms are meanders, which are Oxbow lakes, describe what they're like, and explain their formation. For the next minute, if you could copy the title on the screen, please, Meanders and Oxbow Lakes, and you will need a pen, a pencil, and a drink of water. You've got 1 minute to get all that sorted. Don't forget, I will ask you to pause the video rather than waiting for that minute. So pause the video now. Okay, the do now task. List the key terms that you can see or could use to explain anything in this photograph. The challenge there at the bottom, define as many as you can. I'm going to go through the various keywords I think you can find here. I'm not going to do definitions because that will take a little bit too long, so I'll let you check those through your notes in your book. You've got 5 minutes to list and define as many words as possible. Pause the video now. Okay, so here's the answers I suggest. You may have come up with more. These are the ones that I could find. The ones with arrows are showing you where they are located. All the other ones, less things you can actually see, but words that you could use to describe and explain what is happening here. Some of them kind of hidden, such as the bed of the river, where you can't technically see it because the water's in the way, but we know it's still there. And knowing that this is the upper course of a river, hopefully you could describe that as a shallow channel, so the bed not too far down under that water, also quite narrow. Those are the kind of things you're looking for. So anyway, I'll give you a bit of time. You can pause the video and have a look through these and check some definitions. So back to the lesson at hand, Meanders and Oxbow Lakes. We are moving down the river. And we'll have a little think about that in just a second, but no longer are we in the upper course. And yeah, to remind you, we're identifying and describing meanders and Oxbow lakes and explaining their formation. So what is a meander? Well, it's a bend in the river, really simple. It's no more complicated than that. You can see a couple of great examples on the screen right now in that photograph. It's as simple as that. You've got 1 minute to write that down. You probably won't even need that. Okay, so you've written that down. What course of the river is this in? Well, I've already told you it's not the upper, and you should be able to clearly compare this photograph with the do now photograph. Is it the middle or the lower though? Can you tell from this photograph? Have a minute, have a little think of it, pause the video. Well, it's the middle course. If you look at this photo, perhaps this one makes it a little bit easier to tell. The river itself is wider now. This is definitely no longer an upper course channel. Notice the land around it is certainly a lot flatter, no more V-shaped valleys. Although the if I just use my laser pointer here, you can see this the hill, I guess you could call it, in the background. This is perhaps the watershed for this river, the edge of the drainage basin where any water is going to flow down into the river. If it falls here, it's still not that flat. There is still a hill there. If it was really flat, almost so flat we couldn't even tell, that might therefore be the lower course. But this is usually found in the middle. Some more photographs of meanders for you. And this is particularly extreme, an interesting version of one. And here, quite a small meander. You'll notice not all rivers are the same. This river here is pretty small. In fact, narrow enough you could almost claim it's in the upper course. Rivers in the real world don't always fit the textbooks. So get thinking, where can you see evidence of river processes occurring? It's a word we introduced 2 lessons ago. See what you can remember, see what you can note. 1 minute, have a little think about it. Pause the video. Okay, so here are the 2 main processes going on here, and the evidence arrowed there for you. So erosion. You can see hopefully fairly clearly where some of the bank of the river, the grassy areas there especially, are dropping down into the water. They are being eroded away. And there on the what we call the inside of the bend of the meander, we've got deposition. Looks like a little beach. Some people, in fact, call it a river beach. We're not going to call it that. We'll give it another name later on. But this is an area of deposition. You can tell, can't you? Because it's clearly sediment. There are stones, pebbles, gravel. It's a bit hard to tell, but there is definitely a build-up there of sediment. It's not covered in grass, which shows that it's been put there maybe slightly more recently. So, a sentence to write. We're going to start explaining this. We've seen what a meander is. We've briefly thought about where they are and some of the processes going on. Well, now let's get some more detail in. So, copy this sentence for me. The fastest flow of a river is is around the outside of the meander. So if you have a look here at this GIF, and it will just loop, hopefully. Why? Well, look at these cars, especially those two there, the pink and the red, white, and blue one. Why is it that they're crashing into the outside of this bend? Let's watch them one more time. Bash, there they go. Everyone perfectly safe in that crash, by the way. If you carry the video on, the cars actually all drive away. Why? Well, it's basic momentum, isn't it? The speed of those cars. If you look at them, there's a reason the red car, the pink car, and the red, white, and blue car all crash. It's because they're going noticeably faster than all the other cars. So their momentum is taking them into the outside of the bend, where the other cars, notice here, some cars, there you go, look, these guys coming around the corner, they're all fine. In fact, they're hugging the inside of the bend. Why? Because they've slowed down. Now, obviously, water doesn't have an accelerator or a brake pedal, but the principle is the same. If the water has enough momentum, if it has enough speed, which in the middle course it will, remember the Bradshaw model and the fact that the water in the middle course has increased its velocity, its speed, since the upper course, the water is going to crash into the outside of the bend. So, have a look at this. Keep your eye on the date in the top left and you'll see when it loops. This runs from 1984, or 85, I think, sorry. That's my wife's phone pinging in the background. 1985 up to 2013, I believe. So over quite a couple of decades, you can see this river changing. Now, at the moment, it might all seem a little bit chaotic, so we need to break this down and this process. This is essentially what we're learning about today, exactly what's going on here. So if we look carefully, we can see the deposition we identified before. Here on the inside, you can see the kind of grey area, and we can see, well, can't really see actually, but there is going to be erosion occurring on the outside of the bend, just like that photo we saw earlier. We've got those two processes going on, deposition on the inside of the bend and erosion going on the outside. Remember, this is the inside here, this is the outside here. Let me get rid of that laser pointer, and that's the main thing that's happening here. As we established before, why? Well, because the fastest flow, the momentum of the water is taking it around the outside of the bend, so that's where all the energy is. Remember, deposition occurs where water slows down and it loses its energy. So on the inside of the bend, we've got slower water, less energy, so the sediment is deposited. So here we can see how the river has changed. The outside of the meander has increased its size. It's moved, hasn't it? And it's moved in this direction here. The outside of this bend has moved in this direction. The outside of this bend, or this meander, has moved in that direction, whereas the inside of the bends, here, here, and here, have also moved in the same direction. The river itself is moving, it's migrating across the valley, across the land. So these meanders have increased in size. Well, not increased in size, but they've moved. The area that I'm going to highlight now, he says, laser pointer, there we go. This area here is called the neck. So this is the neck of the river. The neck is where the deposition, the erosion continues to happen, and it is going to change. Well, let's have a look. There we go. So the neck has cut through, and we now have essentially again one main river channel. The river channel itself is now just flowing, the water flowing up here and straight through here and off in this direction. The meander itself is now no longer have water flowing through it. So what happens? It slows down and deposition occurs. The main deposition is going to occur here. This is where the sediment from the river is flowing into and is getting deposited here as it loses energy. And then we move to the final slide. And now you can see that large area of deposited land, and in fact so much so that there's now grass growing on it. And this is now an oxbow lake. We have our oxbow lake here. This is the oxbow lake, and the river itself, like I said before, just flowing in a straight channel. Although there'll be erosion going here, there'll be erosion happening here, there'll be deposition here. In fact, you can see it there. There's deposition there. This river will continue to change, will continue to migrate, may form other oxbow lakes. If you look carefully, you can see various shapes on this land that could very well be. There's one there. There's one there. These could be, you can see some faint lines kind of there. These could be old meander scars. This could be where the oxbow lake has dried out. So let's have a look at this once again. Hopefully this makes more sense now. Remember, erosion going on the outside of the bend, deposition on the inside, the meanders growing in size, their neck getting narrower and narrower. Eventually it cuts through. There's the cut through. Deposition occurs more, leaving the oxbow lake cut off from the main river. And like I said, eventually it may even dry out and form what's called a meander scar. There we go. Okay, so over to you. You've got 4 diagrams to copy. I'd like you to draw an arrow in the channel to show the fastest flow. Where is that point going to be? If you can't remember, go back, find out what's the rule. Shade in one color, like I did, where erosion will occur on each of these diagrams. Shade in another color, where deposition will occur. And finally, label on them where the neck of the meander is being eroded, and finally, where the river is cut through that neck to make a new course. You've got 15 minutes to do that. You should pause the video now. Okay, so I'm going to go through well, 2 things here. Number 1, this is where the neck of the meander is eroding, and this is where the river is cut through to make a new course. If we're going to draw where the fastest flow is, don't forget it should be going on the outside of each of these bends, of these meanders. It should cross over the river and go around the outside. On this one, it should be going around the outside of that bend, the outside of that bend, the outside of that bend, and there we go. Here, however, here's where a common mistake is made. It doesn't go around the meander anymore. Water does not take the scenic route. It's going to take the most direct route. And here again, it's just going to take the most direct route possible. Has no decision-making skills to be able to go around a corner. So erosion happening on the outside of each of these bends. There's erosion. And on this diagram, notice the points of erosion getting closer and closer. Here in C, not really any erosion anywhere particularly, and the same with D. Let's go to deposition, inside of the bends. Where is it going to be occurring in C? Well, it's going to start to be occurring in this area, isn't it? We're going to get some deposition occurring here, which is why in D, the oxbow lake is cut off. So there we go. There's your colours. There's your labels. Let's move on. So now you've done that, I'd like you to write a paragraph for each of these diagrams, describing, say, what's happening, but also explaining why. There's a list of key terms to use there. If you need to, this is the opportunity, this is the time to go back, re-watch through some of the teaching, go back, double check that your diagrams are all correct. It should take you roughly 10, maybe 15 minutes. Try and do it in 10 minutes if you can. Keep it concise, but try to use those key terms and make sure you are explaining why these things are happening. Why is that eroding? Why is that depositing? Pause the video now. Okay, there's one final thing we need to look at, which is a cross-section of a meander, because as you can see already, it is asymmetrical. And this is an important part of understanding meanders, and we've done all the work for it. We should be able to explain why this is happening already. So if you look carefully at the diagram, you've got, well, the inside of the bend and the outside of the bend. We know that on the outside of the bend, think back to those cars, that's where erosion is going to be occurring, and that's where we get our river cliff. So our river cliff here, it is quite literally a little cliff on a river. The bank on the outside here, as it says, is being undercut, cut under here by lateral erosion, sideways erosion. Why? Well, again, go back to the cars, because the most momentum of the water is here. This is where the fastest flow is. The fastest current, it points it to here. This is actually inaccurate. In a minute, you're going to be having a look at and a think about where it actually is. I think what this arrow is showing is that the fastest current is just generally on this side. And actually, that point there is inaccurate. Yes, here we've got fine material in suspension being carried in the water. This side, the slower current, so we get deposition. And this is a landform called a slip-off slope. You've been seeing them quite a few times already. Those grey areas in the satellite images, for example, of sediment that build up. Like I said, some people call it a river beach, technical term for it, a slip-off slope. So there we go. A couple of keywords at the bottom there to have a look at if you don't understand. And a simple task to start with. 5 minutes. I need you to copy the diagram, the title, and the annotations. And in a minute, you're going to do some questions about them. You can pause the video now. Okay, so a few questions, 3 main questions and 1 challenge there. Give them a read. Please answer those in full sentences. Again, if you're not sure about something, you can always go back in the video or the PowerPoint and have a look to see if you can work it out from earlier on, or look at your notes. You've got 10 minutes. Don't forget full sentence answers. For example, for question number 1, the side of the meander that is deeper is the inside, or is it the outside? You work it out. You have 10 minutes. Pause the video now. Okay, some answers there for you. I'll let you pause the video, have a read through them. I don't need to add anything to those. Okay, so that's it. Meanders and Oxbow lakes. Hopefully you can identify them. They're fairly simple to see. They're very distinctive. You can describe them. There's lots of new words we've used today, inside and outside of the bend, slip-off slope, river cliff, these sorts of things. And the slightly more tricky task of explaining their formation, using all those processes, using all those key terms, putting them together into a logical sequence. That's where the real challenge is. There's a quiz to do now. Links for that should be in the on class charts. So go and do that. It'll be based on the last few lessons. Please remember to use your school username. Really doesn't help us as teachers if you use random names and we don't know who you are. Please follow that rule. It helps us to know how you're doing, which is what it's all about. Have a lovely rest of your day. Enjoy whatever you've got for period 5, and I'll speak to you all soon. Take care. Stay safe. Goodbye.